Now we are going to discuss the portion of mechanics, and that is normally known as the kinematics. In kinematics, we have to go through with the various concepts like what is distance, what is displacement, how we define rest and motion, how to prove that they are that is relative terms. So all these facts we have to go through in the kinematics. If the body is at rest, we say the body is static. But if the body is in motion, if it is moving, we say that the body is dynamic. So in kinematics, the very first thing we have to discuss, that is motion in a straight line. This is also known as sometimes the linear motion or the particle in linear motion. Now, first of all, we have to go through the rest. That is, body is said to be in the state of rest if it does not change its position with respect to surroundings. So we can also say like this, an object is said to be at rest if it does not change its position with respect to its surroundings. For example, a book lying on a table or a person sitting on a chair are the examples of rest. So they are in the position of rest, that is with respect to earth. So earth is of course moving with respect to space, but when the body is just kept on the earth, that body is supposed to be in the state of rest. Motion, that is concerned with the change of position of a body. So when an object changes its position with respect to surroundings, then that body is said to be in motion. And we will also remember that rest and motion are the relative terms. So we can say now an object is said to be in motion if it changes its position with respect to its surroundings. Now the example for this will be a bird flying in air, train moving on the rails, a ship sailing on water, a man walking on the road are some examples of motion visible to the eye. Motion of gas molecules is an example of motion invisible to eyes because the size of the molecules is very small. So we are not in position or our eye will not be positioned to focus the molecules. Now, our next discussion is that rest and motion are the relative terms. This means that simultaneously a body can be in the state of rest or in the state of motion. For example, if passengers are sitting in the bus, then they are in the state of rest with respect to the inner walls of the bus, but the same passengers will be in the state of motion with respect to the outer objects. That is, bus is moving with respect to the outer objects. So we will find that the passengers are in state of rest with respect to the inner portion of the bus, but the passengers are in the state of motion with respect to the outer objects. So we can say like this, basically rest and motion are relative terms. An object which is at rest can also be in motion simultaneously, that is in the same time. This can be illustrated as follows. So we have just taken this example about the passengers sitting in a bus. The passengers sitting in a moving bus are at rest with respect to each other, but they are also in motion at the same time with respect to the objects like trees, buildings on the roadside. So motion and rest are relative terms. Now we are coming towards rectilinear motion. Rectilinear means right in the straight line. If a particle moves in fixed direction, the motion of this type is called a rectilinear motion or one-dimensional motion. The example is the motion of an ant on a straight wire is a rectilinear motion, or a car is moving on the road in a straight line. That is also an example of the rectilinear motion. A person moving in straight line on the road that is also the rectilinear motion. Now in two-dimensional motion, we consider a plane and object is placed on the plane. So this object will be in two dimensions. It has two coordinates, x and y. That is, x will represent the distance of that particle on x-axis and y will represent the distance of the particle on y-axis. So if the motion of particle is in such a way that its position remains on the fixed plane, then motion of particle is called two-dimensional motion. Any particle which is in two dimensions must have two coordinates, that is x and y. For example, the motion of a rolling ball on horizontal plane on Earth's surface is a two-dimensional motion. Three-dimensional motion means that a particle in the space, that is above the surface of Earth. So we find that in three-dimensional motion, an object which is in the space has three dimensions, x, y, and z. So it has three coordinates, x, y, and z. Its representation can be on x-axis, the y-axis, and the z-axis. If a line or plane is not fixed for a motion of particle, then its motion is called the three-dimensional motion. For example, the motion of flying birds is a three-dimensional motion. Now we come towards distance. When we speak distance, it is the length between the two fixed points without any reference to direction. So that is what is known as distance. Its serious unit is centimeter, MKS or SI unit is meter. If we want to write its dimension, it will be M naught, L, and T naught. So distance can be expressed as follows: the length of actual path between initial and final position of a particle in given interval of time, and that is what called distance covered by particle. The characterization properties of any path, that is, path is always associated when we consider distance between the two positions. Distance between A and B while moving through path 1 may or may not be equal to the distance between A and B while moving through path 2. So in the figure, A and B are the 2 points. Now one path is indicated, that is in a straight line. Other path is indicated in a curve. So there are 2 paths. So the body is moving from A to B, and it is not necessary that the direction is same. The body can move in terms of in a curve or in a straight line. So distance means that is the length between the 2 fixed points that can be traced by particle either in straight line or in the form of a curve. Characteristics of a distance. It is a scalar quantity. It depends on the path. It never reduces with time. Distance covered by a particle is always positive. Dimensions will be, as I have explained you earlier, it is M naught, L1, T naught. Units in series system are centimeter, and in SI system it will be meter.